Hello, guys. Welcome to the very first episode of Go-101. My name is Dennis, and I'm very excited to facilitate this session. Today, we're going to talk about getting started with Go, your setup, your tooling, and your very first steps. But before we get started, let's talk a little bit about Go. Go is an open source, statically typed, compiled programming language developed at Google, and it was created to make building fast, reliable, and concurrent software simple. So Go makes it pretty easy to build software that scales. So why Go? Go has a simple syntax. Go runs blazingly fast. It compiles pretty fast too. Go has a strong standard library, and one of its strong suits is that it has a very comprehensive and simple concurrency model. And on top of that, Go is cross-platform. You can build to Windows, you can build to Mac, and you can build to Linux. So to me, Go feels like Python, but C in performance. So who isn't excited about Go? Now, what we'll cover, we'll go through installing and configuring Go, Go path versus Go modules. Then we'll talk a little bit about what editors and IDEs are available to us, some Go commands, show you around the standard library, and then finally, I'll show you my dev workflow. I hope you're excited. So now installing Go, let's head over to our browser and we search install Go. We click on this. Okay, and let's click on this button here. Over here, you should see setups for Windows operating system, Mac, Linux, and if you want to build from source, you could also use this link over here. So depending on the operating system that you are on, you download accordingly. Once that is done, you head over to the installation instructions. So over here, you see instructions for Linux, for Mac, and for Windows. So if you're on Linux, you just make sure you remove any previous installation of Go and you extract the compressed file or the setup you just downloaded into the USR local directory. So once that is done, you make sure you append the USR local Go bin path to the path environment variable, like so. Lastly, you just run Go version to make sure it's installed successfully. If you're on a Mac, you open the package that you downloaded, then follow the prompts to install Go. Make sure you set the path and you test with Go version to make sure it's installed properly. Lastly, on Windows, you just open the MSI setup that you downloaded and follow the instructions to install Go, and you just check with Go version, and that's it. You're all set to go. Pretty simple. Next is Go path versus Go modules. Now, in the past, in older versions of Go, all your development files in Go, your compiled binaries, your packages had to live in this one directory called the Go path, and dependencies were managed manually and globally, which was very painful and inefficient. You couldn't have uh, two versions of the same package or the same library, and it was hell, right? Now you don't have to deal with it anymore. Um, let's head over to the browser and search Go path directory. When you search Go path directory, you can look for uh, Golang VS Code Go wiki. Over here, you can see, uh, yeah, they talk a little bit about the Go path environment variable. It's a fundamental part of writing Go code without Go modules. So recently, or in recent versions of Go, there Go modules has been introduced as the new approach to creating projects in Go. So in the past, you had to work within the Go path, right? It specifies the location of your workspace and it defaults to the home directory slash go. A Go path directory contains so the source files, your Go development code, then your bin, your compiled binaries, and then your packages, the installed packages. Your code is typically located in the Go path src or source directory. Now we don't have to do this anymore because of Go modules, which makes it incredibly easy to manage dependencies. So you can have a per project or per module dependency management, and any project that you create can live or reside anywhere on disk. Uh, Pretty cool. And it also helps with reproducibility a lot. We're going to see how that works in action very soon. So, as a rule of thumb, always go with Go modules, not Go path, as that is the recommended approach to creating modules or projects in Go. Now, what IDEs and editors are available to us? I'm sure most of us folks are familiar with VS Code, the likes of um, Cursor and Windsurf. Yeah, VS Code has a wide support for Go. It has pretty cool extensions. You could install and check that out as well. Then there is Goland, which is a JetBrains IDE tailored for Go, which also comes packed with a lot of Go development stuff. Pretty cool. And then finally, there is NeoVim. Uh, NeoVim which also has a very good support for Go. And that's what I'm going to be using in this session. So you can head over to your browser and search install VS Code if that's what you want to go with. Click and you can select which operating system you're on. Yeah, so if you're on Windows, download for Windows, Linux, and then if you're on a Mac, you download accordingly. You can also search for Goland. It's called Goland. Yeah, download Goland. So you download accordingly. Very simple. And lastly, download or install NeoVim. You can go to NeoVim Home and install now. It has a lot of pretty cool plugins that you can work with Go. So yeah, if you're on Windows, you can go through this. Um, use Winget or Chocolate or Scoop. If you're on Mac, you can also go through and follow these instructions. If you're on Linux, you could go through these instructions as well. There are sub uh, Linux distribution specific instructions you could follow as well. If you're on Arch, follow these. Debian, Fedora, etc. Yep. Yeah, so that's it for IDs and editors. And now the fun part, enough with the theory. So the way to initialize or create a Go project is with Go mod init. You do so by typing Go mod init, then the project name. So let's head over to our terminal or whatever, if you're on Windows, your CMD, I guess. So we are going to do Go mod init, and let's call this my program nicely. Uh, but before that, let's create a directory. So make the my program cd into program, and I'm going to run go mod init my program as the name of my module. So we can list and we can see the go.mod file, which is the modules file that we talked about. So let's get into it. You can see only the go.mod file. I'm going to create a main.go file, enter the main.go file, and already you can see it yelling at me because we have to do this. We're going to talk about this in a bit. And this is the very basic structure of a Go project, you have your modules file, which lists the dependencies you install or the dependencies you work with. So this is the name of the module, my program, and the version of Go that you're using in your program. You can change this if you want to say Go 1.24.0. You can do that if you want, or just change it back to this version. Okay, so let's go back to the slides. And now we know how to initialize a project. Very simple. Go mod init and the project name. And we've talked about the project structure. This is the very basic project structure you ever see. And as your project grows, as it gets more complex and complex, you can adopt other project structures that are out there. And if you can use Go mod tidy to clean up dependencies, to clean up hanging packages that you're not using in your project, or to try to look up and install packages that are used in the project but aren't installed yet. So Go Mod Tidy will do that for you very nicely. Now this is a very basic Go code structure. Let's try to recreate that over here. So in our main.go, we have this package main. Now every file in Go lives inside of a package. This package happens to be the main package, which is a special package in a Go module. It indicates that that is an executable, but this file is an executable. And we can have the main function, as you'd see in most programming languages, as the entry point of execution to the application. So in the main function, what can I do? I could do a print hello world. Very simple. And how would we run this? We could just do a go run, then the current directory, and the compiler looks for the entry point, looks for the executable essentially. So nicely, go run, then dot hello world. What happens is go run does two things. It first builds the project, it builds the module, and then runs the binary. And then immediately cleans up the binary. It does that really fast so you won't really see it. So what we can do is try to build it. Go build using the build command. So go build should work. Let's list. You can see the my program binary created for us. Very simple. And if you wanted to um, run this binary, you do so by doing this. So go, what's it called? My program. And then you get hello world nicely. So that's what happens when you run go run. You could also do go run main.go, like the file.go, and then that works too nicely. Back to the slides. Here, let's also see how we can import packages. Now I'm using the simple way of writing to the standard output or just printing stuff to the into the console. We could do same with a package called the FMT package. I will first import the package and I will access it like so, fmt.println and hello world. So we can do a lot more with the FMT package than we can with the other print. We will see that in action in a little bit. Yeah. So this is how we import packages. If you have several packages you want to import, you surround this with a, a bracket and then you have your imports. So FMT and math and um, what else? Strings. Yeah. So that's what you can do with, that's how you import packages in Go. Now next are some Go commands. We've already seen go run in action, then go build. We haven't seen go test. I'll show you that in a bit. Then we have go format, and lastly go install. So go format basically formats our code for us. Makes sure that our Go codes are consistent with the Go standard guidelines. It makes sure that any Go code you write is consistent with everybody else's code, so that everything is consistent and nice in terms of indentations, spacings, and ordering of Go imports and all that. Okay, and for the most part, you don't have to be running Go FMT because it mostly comes packed with your IDE or your editor. So NeoVim has it, Show VS Code 2 has it, and Goland as well. Let's check out the test. So we can test, uh, first of all, let's create a package. I mentioned earlier that every file lies inside a package. So I'm going to create a package called math utils like this, and I'll create a file inside of it called main.go. And in the file, I'm going to define its package called math utils. Now I'm just going to create a simple function called add that would add two numbers a and b, which are integers, and return an integer. Over here, we're just going to return the addition of a and b. Very simple. Now in our main file, what we can do is call try to import the math utils and call the add function. So let's do math. So first of all, we have to import, of course. So import, then the way that you import packages, user-defined packages, you first prefix it with the module name, which is my program, then the name of the package, math utils. Then you just do a math utils.add. Very simple. Not enough arguments because we have to pass the arguments. Say 3 and 2, we get the results in a variable. Let's fmt.print line the results. Fmt isn't imported, so I'll just do this, and my editor imports it for me. So over here, I'm just going to run go run dots. Then we have 5, correct, just as we expected. Now, what if I wanted to test this function, this arithmetic function? What I would conventionally and typically do is I would create a file called add. Oh, I call this main.go. Actually, let's call this add.go. Yeah, add.go, because I don't intend for it to be an executable. And I'll create a test file for it called add underscore test.go. And inside of it, I'll give it the name of the package, which is math utils lives inside of the same package as add.go. So in the math utils, in the add test file, I would define a test function called tests add, and which I will create a parameter t, which is a pointer to the type testing.t. I would have to import the testing.t from the testing package in Go, and it comes with the standard library. I'll show you in a bit. So you don't need a third party to run tests. So over here, we can call the add function and pass in, say, 5 and 3, which are the parameters. And what can we do? We can store the result in a gots variable and say this is what we got after running the function. And we can store a once or expected result. 5 plus 3 would be 8. So naturally, we expect that this function, the addition of 5 and 3 would give us 8. So got would be the result of the call to the function add with the arguments 5 and 3, and 1 would be 8. So I would do, if what I got isn't equal to what I wanted, then I would just test, then throw an error and say um, I got got this, no, let's say expected this, but got that. And what I'm doing is some string interpolation in Go. Be zoom in so that you can see more clearly. String interpolation, right? So this D you see here is a string directive or a string verb, um, which indicates that its its arguments would be an integer. So D is for integer, S is for string. There are other string verbs out there, Go verbs out there that you could check out. So expected once, so which is once, but I got. So let's test this. How would you test this? You do so with go test, right? But you need to specify the test file. What I love to do is I love to recursively run all test files in my Go project. So I do go test, then recursively run all the files, and I'll pass some to additional arguments. I want the results of the testing to be verbose, to be more terse, to have a lot of information. And then finally, I want you to show me how my test covers the entire module. So over here, you can see that the test passed and it covers 100% of statements in my program. And there are some more details over here. So let's deliberately trigger a fail. So I'm going to make this 7 instead of 8. We know that this will throw an error. So we're going to run the same thing. And then we get a fail, just as we would expect. And we also get the coverage, and yeah. So that's how you typically test a Go construct, or a Go function, or a package here. And lastly, Go install. So Go install is used to typically install binaries or tools to aid in your development. One tool we could try to install is Go Blueprint. So let's check that out. So Go Blueprint by Melky. So what is Go Blueprint? It's a CLI tool that allows users to spin up Go projects with the corresponding structure seamlessly. So yeah, it's a Go project generator. Very cool. It helped a lot with learning how to structure Go projects. So we can copy this, and you notice that it uses the Go install. So copy this and run this over here. So I'll paste this and it should install within a few seconds. Okay, that is done. And I can run it like so. So okay, these are all ways you could install usage. So yeah, usage. I could just run Go Blueprint. Let me zoom out a little bit. So what is the name of the project? Let's start over. What is the name of the project? Uh, Nothing. Then what, I guess, what web framework you want to use? It's still too big. Okay, let's try it again. So Go Blueprint create. What's the name of the project? Nothing. What web framework, I guess? So I'll go with Gen, my favorites. So Y to confirm. What database? I'll go with Postgres, and Y to confirm. What Git option? Commit. So space and Y to confirm, preparing. Yeah, so as you can see, it's a tool that is pretty useful. I'm just going to cancel this because I don't need it. You could check that out. Did it create it? So it tried to create the project. I don't need it, so I'll just delete this. Back to the slides. So now we've seen go run, go build, go test, and go install in action. Now, earlier I mentioned that you could build binaries in Go to Linux or to Windows or to Mac in just one command. We can do so like this. So let's try it out. Given this program, this is the binary, this main program, we want to build this to say Windows. We would do go build. This time around, I want to um, give a name to our binary. Now, if you don't pass any, let's just see how it works. So go build, then the output would be my program, which is the same thing. My program. To build to Windows, you would pass the Go OS, the Go operating system, the target operating system, which is Windows, and the Go R, the architecture you're targeting. We could make this AMD. Is it AMD 64 or AMD? Okay, let's try AMD. So yeah, so it has to be AMD 64. Yeah, that should build the binary for us. So we can list and oh yeah, we should, since it's a Windows binary, how about we add a .exe and we should see that over here nicely. And I'm going to do file, then my program.exe. You can see it's an executable for Microsoft Windows, blah blah blah. Nicely. You can do same for Linux, you can do same for Mac. If you don't pass these environment variables, then the target becomes the current system you are developing on. Okay, now let's talk a little bit about the Go standard library. So to know what's in the standard library, I'm going to run this in the terminal. Let's get out of NeoVim, run this in the terminal. So over here we can see some packages that comes with Golang Go, like the string package, the sync package, which has a lot of the concurrency stuff, string manipulation, string conversions, sorting, slices, runtime, regular expressions, reflect, path, utilities, OS level utilities, net, HTTP stuff. Very cool. The math package, the maps, working with maps, the log. You have also image HTML, hash, the FMT package that we talked about, errors package, database for interacting with uh, databases. Yeah, so you can see Go has a very strong standard library and a lot more that we can cover today. Yeah, finally, my dev workflow. So I want to show you how I develop, how I use Go in my day-to-day activities, in my work and in my personal development. So in a bit, I'm going to show you. But before that, I just want to show you some of the things that we can do with just the Go standard library. So I'm going to change directory out of this, cd into that, NeoVim, yeah. So let me show you what you can do with, for example, the strings and strings packages that comes with Go. So we have a variable which is storing the string. Here we're just printing it out, and over here we are trimming out the spaces before and after the string. So when we print this, you're going to see that the spaces before and after the string is going to be stripped off or trimmed off. And over here we have replace all, which obviously replaces all occurrences of the comma with nothing, with an empty space. And this also replaces all occurrences of exclamation mark with the empty string. Okay, and over here we can split a string by the space or the white space delimiter by default, just like the way Python's array array or list dot split works, something like that. And over here we can count the number of words in the string after we've of course split it into an array or slice. Once we do that, we can then convert the number that we get into an ASCII, essentially a string. So this ITOA is integer to ASCII. That's what it means. Well, let's also check out what we can do in the concurrency file. So one of Go's superpowers, concurrency, right? So over here we have a model or like a worker function that we assign an ID to, right? So in this function, all we're doing is we're just simulating work that is running in the background. So you're simulating work has started, just sleep for 1 second, and when you're done, print you're done. So this defer keyword means once everything is done in the function, run this. Before or right before the function exits, run this, defer this function. And this just basically tells, I'll talk about it, don't worry. So in the main function, what we're doing is essentially creating a a Go routine counter called Go routine counter called the wait group. So this basically makes sure that we don't make sure that we don't exit the main process without just make sure that we don't exit the main uh, process, right? We make sure all the Go routines are run right after the main process exits. So what is a Go routine? A Go routine is basically a lightweight thread, very small. It starts off as 2 kilobytes, right? Very small, and it can grow from there. But the Go runtime is smart enough to shrink and resize it as it sees fit. So, like I said, this is just a Go routine counter, sort of. Over here, we start the time ticking and we create a loop. We iterate 3 times, and basically means we're just spawning three or just starting off 3 Go routines simultaneously, concurrently. So what happens is by the time this is executed, we would have three of these processes or these Go routines running this worker function, right? That is what is going to happen. Now we wait until all the Go routines are done working, then we print all work is finished. So I'm going to cd into concurrency demo, go run main.go. Then you can see, let's run it again. So you can see that they run concurrently, not in any deterministic order. Worker 3 started first, then worker 1, then worker 2. It's not even accurate to say a worker started first. It's just a matter of uh, which one got printed to the terminal first because they start concurrently. And so worker 2 finished first, worker 2 gets printed first, 1 and then 3. And let's look at how long. So over here we can see we are printing how long it took for the workers to finish doing their work. We can see that it's right around 1 second, which means that each of those three workers were running concurrently or at this almost at the same time. So we see 1 second, around 1 second and not 3 seconds. That is very cool. Lastly, we have HTTP. You can easily create basic router or server in Go using the net HTTP package. So we've just registered a router which is listening at this endpoint. So when we hit this endpoint, do what is in this handler. We are just writing to the response writer, hello from Go HTTP server. So something similar uh, in say Express. Yeah. So over here you can see I have spawned. I am I am starting the server in a Go routine in a background process essentially. When I do that, I can then simulate a GET request to the server. If there's an error, I log it. Once everything is done, before the function exits, I want you to run this and read the body, print out the body. So let's test it out. CD out, CD into HTTP demo, go run main.go. So the program started, the servers got started, and then we simulated this GET request to the server. What I'm going to do is um, I'm going to remove this. I'm going to run this in the main process, and I'll delete this as well. So this is supposed to run non-blocking. So it's supposed to run and not exit. So go run. Okay, we imported something we didn't use. This is something that Go hates. So go run, then there's real lesson on this server. We can head over to our browser and search localhost 8080. Then we see what happens. So hello Go HTTP server. Very cool, very simple. In just a few lines of code. We didn't even have to install any third-party library. And that's it for the standard library. We can do so much more with the standard library. So here, now my dev workflow. So I am on the Boachie of Linux distribution operating system. Yeah, and I use NeoVim as my primary text editor. You're probably wondering how I got here, how I found myself here. So when I started out coding, I was on a sixth generation HP computer. It was very old at the time, and it had only 4 cores. Um, I don't quite remember the specs, but it had pretty low specs, and I had Windows running on it, right? The processor was slow. I had about 4 or 8 gig RAM, and yeah, I had Windows running on it. It made me really sad because m- running Windows on my laptop was very slow. And on top of that, the IDE I was introduced to was JetBrains, and so that was what I was using. JetBrains was also resource intensive. So I was unhappy 100% of the time. I couldn't run more than one instance or one window of PyCharm. I was using PyCharm. I couldn't run more than one. My PC would just freeze. So moving on, I was introduced to Linux, Ubuntu, and it was just fast, right? It was just fast. I fell in love with it. So I decided to go with it for a while. But there was still the case of having to deal with PyCharm or the JetBrains product because I that was what I was introduced to, so that was what I was using most of the time. And I discovered that so in my pursuit, right, to finding uh I decided to look for lightweight alternatives to uh JetBrains, right? So I discovered NeoVim. Actually, it was Vim I discovered first, and I heard it was light, it was fast, it was efficient in text editing. It had a lot of magic in there. It sounded fun, but then I also had it. I also needed to work, so I had to get some work done. So I had to stick with JetBrains for a while um, learning the Vim motions, right? While learning the Vim motions in JetBrains. So I was using the Idea Vim plugin, which is the Vim bindings Vim plugin in the JetBrains software, I guess. So I spent time working on that for a while, and I got better at it. So I decided to move to transition fully into NeoVim. And when I did, I was the happiest developer on the planet. I was so excited. Everything was just wonderful and fast. So yeah, recently I decided to, well, because of NeoVim, right? Because of NeoVim, any environment that I find myself in, I want to be as efficient as possible. Because NeoVim is keyboard driven, right? I also want to have a desktop environment that is also keyboard driven, which is why I went with Boachie. Um, comes with, it is running Arch Linux under the hood, and it comes packed with Hyperland, which makes it possible to be able to switch workspaces like I've been doing during this session. So yeah, enough talk about NeoVim and the Marchi. I just want to show you some stuff that I can do in NeoVim. So over here, let's see. I could just I'm just going to jump to the set line, and I could just so I'm going to jump and clear out whatever is in the over here, whatever is over here. So this, and then that is done. Very simple. I could also clear out whatever is inside the brackets, like so, just a few key bindings, and then that is done. I could clear out whatever is in the function. I could jump to the top of the file, jump at the bottom of the file. If I make a typo in, say, um, the guy is good. Let me do it again. So the the guy, and then I make a typo. I could just quickly swap this, swap so fast, and this is just so cool. I could just delete lines effortlessly, right? Undo, redo, and I could also what could I do? Could copy stuff, highlight stuff, move stuff around. I could split windows horizontally and vertically if I wanted to. I could resize them, could open my file explorer. I could open a terminal from inside NeoVim. What happened? Okay, from inside NeoVim, resize that as well. I could quickly search for files. So I could fuzzy find files in my directory, main.go. I could also search say main.go or okay, they are all main.go's. But yeah, essentially you could fuzzy find and you have a very nice preview on the side. You could also you have auto completion just like in your IDE, so http dot get, right? And then you get all these auto completes and uh, documentation pop-ups very nicely. What you can also do is what else can you do? I think that's mostly it. But yeah, there's a lot. I can show you everything you can do in just this one session. But yeah, that is why I love NeoVim. Is very cool. It's efficient, it's wizardry, it's fast, it's powerful, it's NeoVim. Yeah. So if you're interested, you could check out NeoVim out, and I'm sure you'll love it. I could also, in terms of aesthetics, NeoVim can be very, very nice. I could change the theme that I'm using. I'm changing this system wide, which would affect my NeoVim, but that's not a problem. Set it to Nord and change my theme. I could set it to Everforest. That would change my team as well. I could change it to Osaka. Let's just take it back to Tokyo Night. Yeah. And then yeah, there's Hyperland on the Marchi. You could just switch between these windows, switch between windows, move these windows around nicely, create a lot of them and just be moving them around, switching between them, changing the layout horizontally or vertically, moving them around. This is fun, isn't it? Very efficient. Yeah. So that's why I love Linux and keyboard driven environments. They are built for productivity. Now I want to show you one project. What project can I show? So I'm going to change directory, go back. Okay, let's go into Go Ghana, and go into Go GH server. Okay, let's work with this. So this is NeoVim, and yeah, check out this project structure. This follows the CMD internal project structure. This has been tested by the Go a lot of developers in the Go team, and it is recommended especially for larger projects. If you have a very simple project, this might be an overkill. You could also check it out, read more about it if you want. But yeah, this is a very good structure for complex projects. You could have several entry points in your CMD. You could have um, packages or code that you don't want other packages importing from, and you have other packages like that. But what I want to show you is how I work with makefiles. If you come from a C or C++ background, you've probably worked with makefiles. So what I use makefiles for is I use it to I use it as shortcuts to running commands. Uh, Most of the time, really long commands. Or if I just don't want to type out the commands in full, I just use makefiles. So I can define a target which is a build, and the recipe for that target is this, what I would typically run in the terminal. Go build, blah, 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 go run, blah, blah, blah. Essentially, any command that you would run in the terminal normally. If you're working with Docker, you might want to use makefiles because sometimes the commands can get really long, or even Kubernetes. So this is my approach to running commands or giving shortcuts to commands, right? And let me just test it out. So instead of running a go run and the CMD API main.go, I would just do a make watch and it runs it for me, right? Make watch and it runs it for me. And my server is running the localhost 8080. Yeah, nicely. Isn't Go lovely? No, this isn't really Go, but like, yeah, I just love the way I develop with Go. And the next thing I want to talk about is SQLC or SQLC. Now, um, I hate working with ORMs, right? I'm a big uh, I'm a big Postgres fan, probably because of PostGIS, the spatial extension, because I work with spatial data a lot. But that's not why I hate ORMs. I hate ORMs because ORMs are bloated and they are slow. And for every programming language that I would work in or I would develop in, I would need to how to um, know how to work with an ORM in that ecosystem, which is painful. So when I started out learning Go, I discovered SQL which SQL C, which compiles uh, it takes SQL queries and then compiles them to type safe Go code. Very cool. So all you have to do is just define your queries over here. Define your queries. What database functions would you need in your application? What services, what database services would you need? So I would need a get member service. So select star from members, the members table, right? Where ID is equal to this parameterized argument. Another get member by email, select star from the members. So this is actually an SQLite database that I'm working with, not actually Postgres, but yeah, still SQL. And once I have this, you also need your migrations file, the schema for your database. That's all you need. You don't even have to connect to a database in order for SQLC to work. That's another thing I love about SQLC. So with your schema and your queries, it just generates your type safe Go code for you, and then you use them in your handlers, in your APIs, in your controllers, whatever you like to call it. So what I would do is run make SQLC, and the underlying recipe for the target is SQLC generate, and that generates this code for me. In SQL C, I get my models. So I have my members model, first name, last name, email, blah, 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 generated for me. I mean, don't get me wrong, you could do it yourself, but you will realize that with time, you realize that this can get really repetitive when you're working on a really large project or really large code base. You can see that you will see that SQL C can come in handy. Yeah, so my models, and when I go into members, you can see the functions that were generated from my queries. I don't remember seeing this, but let's see. Members, let's look for get member to get members over here, right? The query that we curated and the function that it generated for us. So you have control over the queries, over the functions, and you don't have to depend on any ORM. So this is like the flip side of ORM, except you define what functions you want to use, what parameters, what returns from those queries, and all that jazz, which is very cool. And in NeoVim, I can visualize or I can interact with my database using a NeoVim plugin called NVim NVMDB, I think. Yeah. So I can connect to my Go-Ghana database and I can do select star for members, but I don't want to show the members, but you can see it's up here, down here, sorry. Yeah, I could do a delete, delete from members. I could do this, but I'm not going to run this. This is dangerous. So yeah, I could switch between this and my editor like very quickly with just a few key bindings. Yeah, so that's it for SQL C and NeoVim and Makefiles and Omarchy, I guess. What else is there? Yeah, so guys, that is it for my dev workflow. I can show you everything in just this one session, but I hope you can take something away. I've shown you the predecessors that I'm using, my editor, some tools that I've been using. Uh, yeah, I forgot to even mention this one. There is also one I use for my database migration called Goose. And Goose, I love it a lot because it's just great. I can, it does all the things that database migration tools do, keeps versions very neatly. I have been doing a lot of migrations, but I could check it right now. Make goose status like this, and nicely you get your changes, you get uh all the changes essentially you've made to your database via the CLI. Very cool. Yeah. So I love Goose. You could check it out. Interestingly, these tools were created in Go. SQL Go, Goose, Go. My database CLI backend was created in Go. Go is the future, bro. Go is the future. Yeah. So going back to the slide. Yeah, so this brings us to the end of this first session. I hope you enjoyed it. I know it's a lot, but don't worry. I just wanted to introduce you to and show you the kind of things that Go can easily do out of the box, and wanted to sort of motivate you to get up to speed with Go. There's a lot of interesting things that Go can do, a lot of things that we can talk about. So if you have any questions, you can drop it in the comments, and we will reach out. If you want to reach out to us too, you can visit Golang Ghana and then send us a message. Don't forget to subscribe and join our Discord server. Enjoy.